Okay, we're looking at number 7. If you listen to my previous video on one of the previous problems, I think that was number 3. That may help you on this one, at least to set this thing up. You can see you got 2 legs of a big right triangle, and you've got an altitude drawn to the hypotenuse. So you're probably going to use the leg rule, right? Doesn't seem like our altitude is involved at all. Although we could get it involved, it looks like it would be a lot more hairy of a problem, because why are we adding another variable to our problem, right? And actually, this is another form of our 3, 4, 5 right triangle, because we got 6 and 8, so that's 3, 4, 5, all multiplied by 2. So you can do Pythagorean theorem, but I'm telling you, 100% guarantee, 100%, this is going to be 10. Go ahead and do Pythagorean theorem if you want. Okay. So that gives us the hypotenuse, and x is the projection of this side AC onto the hypotenuse. So if you were to imagine, this thing casting a shadow onto the hypotenuse, looking straight down from the vantage point of, somewhere over here, you'd see that the shadow would be right here, or this part would be blocked by side AC. You couldn't see it if you're looking like straight this way. Okay, so that's called the projection. Now remember, the formula is the leg squared equals the projection of that onto the hypotenuse multiplied by the hypotenuse. So it's 6 squared equals x times 10. Okay, and that gives you the formula. Okay, I went ahead and did Pythagorean theorem for those of you weak ones out there that can't do the 3, 4, 5 right triangle times 2. Anyway, we got 6 squared equals x times 10. You could take 6 squared and multiply it, but you know me, I don't like to do anything I don't have to. I divide by 10 on both sides. The 2 goes into 6 3 times. I get 18 over 5, which is acceptable at this point, or 3.6 if you want to go ahead and take 36 divided by 10. Okay, either one of those would be acceptable. Okay, let's, I guess nobody asked for number 8. I'll just do a real quick run through here of how to do that problem. You're finding this part here is 200 times tangent of 18. You're using this little triangle to find basically the height of this cliff, kind of, before you get to the lighthouse. And once you find that, you take x plus that for this side, using this big triangle, which has an angle of 28. So you have tangent of 28 equals this opposite side, x plus this number, over 200. Then you solve for x plus this number, and then subtract this number once you solve, right? So you see the algebra here. If you want, this will be on the answer key that I upload. Okay, let's see how much more I can fit in the video. I only went 3 minutes, so I can do a little bit more here on this video. They give me, I think, a 15-minute or a 10-minute max. Okay, for the free version. So we're looking at, the ladder against the fence, against the brick building. Very famous, math trigonometry problem, because we're always looking for the angle that our ladder is. You never know when you're going to be passing by a construction site and a construction worker's like, hey you, and you're thinking, hey, is he hitting on me? Am I looking kind of cute today? I don't know. Maybe he thinks I'm cute. I'm not really into him, but what's he at? Hey, you over there, you look smart. Oh, me? Yeah, well, I took trigonometry one time. Hey, can you help us find the angle of this ladder to the ground? Okay, mister, how tall is the fence? Fence? Oh, yeah, it's 6 foot long. How about your ladder? How long's your ladder? Ladder, why are you asking that? Well, if you tell me the ladder and you measure the distance from the fence to the ladder on the ground, I could probably do some trigonometry. Well, I guess you're pretty smart. That's why I called you. Okay, so the ladder's 15 feet, and the ladder is resting on the ground about 4 feet from the fence. Mister, you're telling me about, is it 4 feet or is it about 4 feet? Oh, it's 4 feet. Yeah, it's 4 feet exactly. I measured it. Pretty close. Pretty good. And the fence is exactly 6 feet. Okay, Mister, let me do it. Okay, so then you're like, okay, I'm gonna make a friend here. I'm gonna make a construction worker friend, and I'm gonna go ahead and do this. And you draw the diagram over here, right? And you got your little triangle over here. You taking the information he told you, and oh, he wasn't interested. Oh, hey, I'm not asking for the angle. I'm actually asking for how high up is the ladder on the building. Oh, okay, mister, but I'm going to have to find the angle anyway. Okay, do what you got to do, man. Do what you do. It does what it does and do what it do. Okay, mister, give me a second. Okay, so then you're like, okay, I got to find the angle anyway because in this little triangle, I can find the angle using tangent, inverse tan of 6 over 4, right? And then once you find that angle, you're going to use this big triangle. And you got opposite over hypotenuse, which is x over 15. So you got, that's the sine. The sine is opposite over hypotenuse, so it's x over 15. And you already found the theta here. If you did inverse tan of 6,4 and you calculated that in the calculator, just keep that answer in there. And then you do your algebra here, and you get x is 15 times sine of the answer. Type in the answer by second negative, and so it's 15 times sine of uh, the answer, and that equals about 12.48, I believe, when you round to the nearest hundredth. Hey, sir. So I mean, I rounded to the nearest hundredth. I hope that's okay. It's 12.48 feet. Hey, yeah, it's pretty good. Hey, that's a smart guy over there. Smart guy. We should we should stop calling on women and saying how beautiful they are. We should just look at these smart guys over here and tell us how high our building is. How high our ladder is on the building, man. That's pretty cool. Hey, come over here and teach me sometime, okay, buddy? I don't know about that, mister. I'm trying to stay alive. Oh, okay. I see what you're saying.